This program, DTFTCOS, demonstrates the response of an LTI system specified by an impulse response, h of n, and its DTFT, magnitude and phase, to a cosine. You specify the system by means of these two vectors here, b and a, which are the coefficients of the numerator and denominator polynomials of h of z in terms of powers of z to the minus 1. So for example, for a finite length sequence, there we go. The top plot here again is h of n. The second plot, x of n, is a cosine whose frequency is determined by the value of this cursor here. So right now the cursor is at 0 frequency, therefore the cosine is a constant. As we change the frequency of the cosine by mousing in the axis and pulling, the frequency of the input changes, and the output shown in the third panel here has a magnitude and phase which are given by the magnitude and phase of the DTFT. You can also change the frequency of the cursor with the slider or by entering a value here. You can also change h of n just by mousing in the axis and pulling it. It shifts it right or shifts it left. When it shifts off screen, there's a little arrow which shows that it's gone off screen. You can center the plots so that you can do both positive and negative time delays around 0 and watch the output change appropriately. By selecting the autoscale control, you normalize this bottom trace to full scale so that when you change the frequency, you can show that for a linear phase system, you always get the same time delay. This program is one of a suite of programs that I have developed to explain DSP concepts to my students during lectures. There are now well over 24 programs covering many aspects of the material in the book, including complex exponentials and sinusoids, convolution, the DTFT, pole zero plots and their relation to frequency and impulse response, A to D and D to A conversion, including upsampling, downsampling, resampling, and aliasing, the design of many types of FIR filters and their application to the filtering of speech and other signals, the design of IIR filters, circular shift and convolution using the DFT, the discrete cosine transform, and the short-time Fourier transform. A selection of these programs is being made available to instructors who are currently adopting the book in their classrooms. For further information, please visit cambridge.org/Holton.